Chapter 9, Lesson 2, Simplifying Square Roots. So we started to work with square roots in the last lesson. Now we're going to move that up and do a little bit more with it. One of the things that's really important to understand about square roots are you can simplify them if you find perfect squares. So I wrote down the first 10 perfect squares up there. 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Those are really important numbers to remember because when you're taking the square root of anything, if that can come up, then you can simplify the square root. So a really important aspect of square roots are if you have any number a and any number b, and you take the square root of a times b, that's the same as taking the square root a times the square root of b. So I know that sounds kind of complicated, but what that means is if you have this, if you have the square root of 4 times the square root of let's see here, 16, okay, that's equal to 2 times 4, which is going to be equal to 8. It's also equal to the square root of 64, which is going to be equal to 8. So that's what I mean by when you multiply things, you can go ahead and break them down that way. Now, when you are simplifying things, the simplest form of these things called radical expressions, that's the stuff with the square roots, are when there's no factor of the expression under the radical sign that has any perfect square factor other than 1. That simply means that, well, 1 is a special case because any number can be, 1 can be pulled out of anything, but you can't break apart the stuff underneath the squared symbol into a multiplication problem that has these factors in it. If you do, then you have to simplify it by pulling out that perfect square root on the outside. So easiest thing is to see this in action. This one here we're not going to deal with right now, but we'll talk about that a little bit later if we have time. So if we were asked to simplify this, 112, the square root of 112, the way we do that is we try and figure out which number divides into those numbers, into that number there, 112. Really, if you want, you can just factor it. If you wanted to factor it, eventually you'd come up with its 7 and 16. And then if you wanted to, you could do 4 and 4, and then 2 and 2, and if you want to do prime factorization. But really, what this is clear on is that 16 is the number that shows up there, that's on that list up there on the upper right-hand corner. So that's a perfect square. So we have to pull that number out. We have to pull that, and when we do pull that number out, we have to divide it. We have to divide 16 into 112, and when we do, we're left with 7. So that's why it breaks it down this way into the square root of 16 and the square root of 7. And what's the square root of 16? It's 4. So it's just 4 times the square root of 7. We're going to practice this a bit more in a minute. Actually, let's do that right now. So here, so what number divides? So hopefully this 63 sort of screams out to you when you look at those numbers what divides into 63. The only one that does is 9. So this is going to be the square root of 7 times the square root of 9, which is just going to be the square root of 7 times the square root of 3. We write that as 3 times the square root of 7. For 24, what number goes into that? It's actually going to be square root of 4 and the square root of 6. So this is going to be 2 square root of 6. So all I'm doing is I'm breaking it down into a problem where I'm separating the factors, and then any perfect square factor I can then simplify. For this one here, it's going to be 25 square root of 25 times the square root of 11. When you do that, that's going to be now 5 times the square root of 11. For 300, the square root of 300, it's going to be the square root of 3 times the square root of 100. And so the square root of 100 is 10, so it's going to be 10, and we write that in the front, times the square root of 3. It starts getting a little bit more complicated when there's a variable, but not too much. So let's look at what it says here. So this one here is, don't forget we got to take the negative of it. This is the only one that has a negative in there. But what does 18 break down to? It breaks down into 9. That's the perfect square, and then 2. I know it can break down into 3 and 6, but that doesn't help us from a perfect square perspective. So, and then square root of 2, or square root of x as well. So then I can simplify this. This could be square negative 3 times the square root of 2 times the square root of x. And so then I recombine them. It's going to be 3 times the square root of 2, or negative 3 times the square root of 2x. For this one here, I have to think what goes into 92. And what goes into 92 is, I'm not sure on, so what I'm going to do is I'm just going to factor it. And when I factor it, what I'm going to see is 92 breaks down into 2, and then let's see here, 46, then 2, and 23. So I have two 2's there, and what I'm going to do is with those two 2's, I'm going to combine them into the perfect square of 4. So this is 4 times 23. That's going to be equal to 92. So when I rewrite this, it can be the square root of 4 times the square root of 23 times the square root of y squared. Square root of 4 is going to be 2. Square root of 23 is just the square root of 23. Square root of y squared is just going to be y. And so when I recombine them, it's going to be 2y times the square root of 23. This one here, same sort of idea here. I'm going to break this down to 9 and 3, and then x squared. So this is just going to be 3x times the square root of 3. Now, similar rules here in terms of quotients and division. If I have this sort of expression here, or in this case here, let's look at the real number 1. Any number a where a and b are positive numbers, and when b is greater than 0, what's going to happen is that I can break it apart into two separate problems here, because that's what's happening here. Instead of combining it, I'm breaking it down. And so here, 45, square root of 45 over a square root of the whole expression 45 over 189, or 169. It's going to be the square root of 45 over the square root of 169. I'm then going to break it down into the square root of 9 and the square root of 5. And that's over 13, which is just the square root of this number here, 169, is 13 straight out. And then I'm going to break the 9 down into 3 when I take the square root of it. And that's going to be 3 times the square root of 5. That's all going to be over 13. So now let's look at these here. In terms of simplifying this expression here, I'm going to write this one up here. It's going to be square root of 40. I'm rewriting it just a little bit, that first step here, 81x squared. So this is going to be equal to, well, this is going to be the square root of 4 times the square root of 10. And that's going to be the square root of 81 times the square root of x squared. So now I can take the square root of 4, that's going to be 2, times the square root of 10. Now in the bottom, 81, the square root of 81 is going to be 9. The square root of x squared is going to be x. And that's going to be my final expression there. I'm going to do this one over here. So now it's the square root of 108 over the square root of 10,000 over x squared. Now 108 breaks down into, well, it breaks down into perfect squares is if you go ahead and break it down into 9 and 12. And 10,000 breaks down into when you take the square root, that bottom part is going to be the square root of 10,000, which is actually just going to be 100, but we can do that in a second, times the square root of x squared. use a different color here because that's a little bit hard to read. So square root of 9 is going to be 3 times the square root of 2. Can't simplify that. It's all going to be over 10,000 is the square root of that is 100. The square root of x squared is just x. And that's all you do. This one here, we're not going to deal with this one here just because we don't have time, but hopefully this makes sense. And that one there's a little bit more complicated, but we'll get to that in class if we need to.